specializing in 5G and beyond. The Holy Grail of 5G and Beyond 5G by D.Sudhir Dixit, sir, Life Fellow of IEEE, San Francisco, USA. Today, we stand before you to shed light on the remarkable benefits that IEEE, the Institute of Electrical and Electronics Engineer, offers to college students like us. IEEE is not just an organization. It is a dynamic platform that opens doors to the knowledge, innovation and collaboration. We stand before you today with immense gratitude as whose unwavering support has been instrumental in the success of our events. We extend our sincere thanks to our Honorable Vice Chancellor of JNTUGV, Dr. K. Venkata Subbaya Garu, our beloved teacher and a focused leader with a vision to improve Indian education to internationally approved standards, and the respected Registrar of JNTUGV University, Professor Dr. G. Jayasuma Ma'am from the Department of IT, Director of Industry Institute, Interaction Placements and Training Director of Faculty Development Cell, and Executive Council Member of JNTUGV for the invaluable support. We are proud to have leaders like them who prioritize students' initiatives and contribute to the vibrant atmosphere of our institution.
We wish to express our profound appreciation to our head of the department, Dr. B. Nalini Ma'am, for the support and guidance in making this event a resounding success. Her dedication and tireless efforts have been a cornerstone of our achievements. Our ECE department deserves special recognition for the support throughout the planning and execution of this event. Our department has been this driving force behind these accomplishments. Their consistency and dedicated assistance has played a vital role in our success. I wish to convey my deepest appreciation to Dr. M. Hema Ma'am, the mentor of our Communication Society chapter and ECE member of VIZAG Bay COMSOC SPS Joint Chapter, for the indispensable role as the backbone of our technical events.
We extend our heartfelt gratitude to the students and faculty members from GVP, GMR and Raghu College for gracing our JNTUGV campus with their presence at this remarkable event hosted by IEEE Student Branch. Your participation and enthusiasm contribute significantly to the success of this event. With your support, we are inspired to continue organizing such events in the future, fostering knowledge, sharing and collaboration. Here's to the success of this event and the promise of many more to come, where we can continue to learn, innovate and grow together.
IEEE is the world's largest technical professional organization dedicated to advance in technology for the benefit of humanity. It plays a significant role in shaping the development of technology worldwide. IEEE organizes events for developing and publishing technical standards, hosting conferences, and promoting research and education. The mission of JNTUGV IEEE Student Branch Chapter is to provide every assistance possible so that students can learn and enhance their technical knowledge and managerial skills. We at JNTUGV IEEE strive to provide various learning facilities that will help students in developing a wide range of skill sets ranging from soft skills to technical projects, etc., which will help us to become a better human and thus to set the trend for others to follow. Our student branch is looking forward for organizing a good number of quality events in the coming months with the excellent support and guidance from our branch counselor T.S.N. Murthy sir, IEEE Communication Society chapter mentor and head of the ECE department Dr. B. Nalini ma'am and IEEE SPS chapter mentor Dr. M. Hema ma'am.
IEEE is an organization with staggering membership exceeding 4 lakh individuals, boasting over 340 local sections which held over 2,000 conferences. Some of the past events conducted in JNTUGV are WIE STB Group organized event on challenges faced by women and gender equality, organized talk on 5G and the future vehicle to everything, PCB design workshop and Arduino workshop which opened the doors to the world of microcontrollers. A COMSOC SPS joint chapter focuses on areas related to both communication and signal processing, which can include topics like wireless communication, data transmission, signal analysis and more. These chapters typically organize events, workshops and conferences to promote knowledge, sharing and network among professionals and researchers interested in these fields. COMSOC SPS Joint Chapter helps students in educational experiences, fostering professional development and preparing them for successful careers in the field of communication and signal processing.
Now, I would like to mention the chairperson, the vice chairperson, and the secretary of VIZAG Bay section, Dr. Abraham Varghese Garu, Director NSTL, the vice chairperson, Mr. K.V. Sriram Garu, CEO of Andhra Electronics, secretary, Dr. Anil Chapala Garu, senior scientist, NSTL, and past chairperson, Professor S. Lakshmi Narayan Garu from Andhra University. Now, I would like to give a brief about the members of COMSOC SPS Joint Chapter. Professor VVSS Chakravarti Garu, the chairperson, vice chairperson Dr. B. Kishore Garu, NIT AP, Dr. M. Subbarao Garu, Vishnu Engineering College, Dr. M. Hema Ma'am from JNTUGV, Dr. G.V. Sridhar Garu from Raghu Engineering College, Dr. L. Ganesh Garu from GVP Engineering College, and past chair and today's program coordinator, Dr. T.S.N. Murthy Sir from JNTUGV.
Now it's time to invite the guests onto the dais. I would like to invite Professor VVSS Chakravarti Garu, the chairperson of the COMSOC SPS JT chapter, to come on to the dais. Now, I would like to invite Dr. Sudhir Dixit sir, the speaker of today's event, onto the dais. Now, I would like to request Professor VVSS Chakravarti Garu to address the gathering.
Thank you everyone. Thank you T.S.N. Murthy Garu for making a wonderful arrangements over here, being a program coordinator for this event. And I also thank each and every student member. I could see a lot of student members over here, and I wish most of them are COMSOC and SPS student, IEEE student members from their respective student branches. If not so, I also suggest you to take it up. And yeah. So to start with, first of all, I should take the name of your VC, our VC, Vice Chancellor Garu, and the generous attitude of our Registrar Madam. Both of them have really coordinated and with our program coordinator, and finally we got this venue, because having a venue in a university is definitely giving us a wide visibility, focusing on all the 3 districts, which is never a possible case if we organize this in any other private space. So I really thank VC sir as well as our Registrar Madam. And now to again, how this event has come and what is this distinguished lecture. As you know, being an IEEE member, definitely you would be knowing about the importance of a distinguished lecture. This is the very high standard lectures organized by the societies, and as we have a COMSOC, and that is the Communication Society and Signal Processing Society's joint chapter under VIZAG based section over here. So we got an opportunity, and it has come to the notice of T.S.N. Murthy, in fact, for the first time, where he has coordinated the things and spoke to me, and we coordinated with the VIZAG based section. That is, we spoke to our chair, Dr. Abraham Varghese, and our secretary, Dr. Anil, and the past chair, Dr. S.L.N. Garu. S.L.N. Garu is Lakshmi Narayan Garu. So all these have quickly given their consent to organize this event, and this has been a wonderful opportunity to all the participants here. Again, this Communication Society and Signal Processing Society joint chapter in VIZAG based section, we have a new slate which is recently constituted with me as a chair, and the immediate past chair being Dr. T.S.N. Murthy garu, and we also have Dr. P. Kishore from NIT AP and Dr. Subbarao from Bhimavaram, the Sri Vishnu Engineering College for Women, serving as a secretary. In the the past slate, he used to serve the society, the chapter as a treasurer, and now we also have Dr. Hema from JNTUGV, this institute, serving as a treasurer, who served the slate earlier as a member. And in addition to this, we also have two other members, one from my institute, Raghu Engineering College, Professor Sridhar Garu, who is also there with us now. And also we have Dr. Ganesh from GVP College for Women. So I am very happy that most of the COMSOC SPS chapter members are here, and I also could see few of the student chapter chairs who have also presented here at the venue. So first of all, thanks to Dr. Sudhir sir, because we have been actually looking for a very good day and finding out, exploring the dates, and finally he has agreed to the convenient day as per our wish. So thanks to him, and thanks to our T.S.N. Murthy garu once again for coordinating the things and having a very big venue over here. And thanks to ultimately the entire appreciation goes to the Communication Society, IEEE, USA, and our VIZAG based section leadership. Thank you very much.
Thank you, sir, for your valuable words. We look forward to organize many more events associated with IEEE COMSOC like this. Now, my co-host will speak a few words about Dr. Sudhir Dixit, sir.
Dr. Sudhir Dixit sir is a co-founder and chief operating officer at the Basic Internet Foundation in Oslo, Norway, and heads its US operations. He also works on the Academy of Finland 6G flagship program led by the Center for Wireless Communications, University of Oulu, Finland. From 2015 to 2017, he was the CEO and co-founder of a startup, Skydoot Inc. From 2009 to 2015, he was a distinguished chief technologist and CTO of the Communications and Media Services for the Americas region of Hewlett-Packard Enterprise Services in Palo Alto, CA, and the director of Hewlett-Packard Labs, India, in Palo Alto and Bangalore. Before joining HP, he held various engineering and leadership positions at BlackBerry, Nokia, NSN, and Verizon Communications. He has been a technical editor of IEEE Communications magazine and is presently a board member, vice chair for Americas and working group chair at the Wireless World Research Forum, WWRF. He has been on the editorial boards of IEEE Spectrum magazine and Springer's Wireless Personal Communications Journal. He is a co-chair of Connecting the Unconnected Working Group. In 2018, he was appointed as a distinguished lecturer by the IEEE Communication Society. From 2010 to 2012, he was an adjunct professor of computer science at the University of California, Davis. And since 2010, he has been a docent at the University of Oulu, Finland, and Vajra adjunct professor at the Indian Institute of Science, Bangalore since 2022. He has published 8 books and holds 21 US patents. A life fellow of the IEEE, fellow of IET and IETE, and obtained a PhD from the University of Strathclyde, Glasgow, UK, and MBA from the Fluoride Institute of Technology, Melbourne, Florida, MA from BITS Pilani, and BE from Manit Bhopal. Sir, we are very proud that your graduation is from India, and we are very fortunate to have you here on this wonderful occasion, and we are eager to learn from you. Now I would like to invite Dr. Sudhir Dixit sir to deliver his lecture.
Okay, good morning, everyone. Good morning. Before I begin, I'd like to thank everybody here from IEEE, IEEE COMSOC, and other societies for extending this invitation to be here and to talk to you all. So my big thanks to all of you from the faculty, from all the colleges and everybody else in the organizing committee. I also want to thank all of you who have found time to listen to my lecture. And I'm particularly thrilled to see so many young faces, undergraduates. I think most of you are doing undergraduate. Is that correct? Are there any postgraduate students here in the audience doing masters or PhDs? Probably not. So I'm even more happy to see undergraduate students because your career is ahead of you, and oftentimes you probably wonder what are you learning during your engineering courses. Of course, you are going through a process whereby you are building the foundation for your career. But it's never a good idea to think that you are learning certain basics that you will not use in your professional life, whether you choose to be in academia, in the industry, or in the government. Are you able to see this from the back? Okay, so since most of you are from undergraduate, and the talk that I had organized or I was thinking about was more from a research perspective about 5G. I'm sure you all are using mobile phones. Some of you have more than one phones, more than one SIM cards. So you're probably familiar with 3G, 4G, and now 5G that has been launched in many parts of the world, and in India as well. Okay, so my talk today is about network slicing in 5G, and I'll tell you what network slicing is. But before I do that, I'll go to some of the basics about networking, about internet, and I'd like to see from a show of hands how many of you are doing courses in computer science, software engineering. Can you raise your hands? Software, IT, and how many of you are doing a course in electronics, electrical engineering, telecommunication, and communication? A lot of you, which is very nice. So that makes my job a little easier. So whenever we think about electronics, we think about transistors, we think about LEDs, we think about optical communication, wireless communication, and so on and so forth. That's all great. Those are very fundamental concepts. And all of those concepts come together to build a network that we all use in our day-to-day life. However, the network that we use to make a mobile call is all packet based. It's not circuit switched. For some of us and some of the faculty who are probably over 30-year-old or 40-year-old, they're familiar with circuit switch technology. But you are growing up in an era of packet switch technologies, which is utilizing the internet. So basically, when you think of a mobile network or a communication network, you have a backbone network, which is the internet core, which is built of fibers, mostly fiber communication network that is carrying packets with a header, and it is being transported from one end to another end. And from the mobile perspective, when you speak on the phone or you're running an app, it gets packetized, whatever information you're trying to transfer, and it goes over a radio network, and it hits the terrestrial network wherever your tower is. From tower to your mobile phone is the radio. And we need radio because we want to have a mobility. We want to be able to connect from anywhere. So that's where the radio part comes in. And once you hit the tower, then everything is going through a wired network. Or it could be a cable, it could be a microwave. It's really not a microwave, but it is mostly fiber. So from the tower onward, it is mostly a fiber network. So radio only provides a mobility, and everything is happening in the wireline communication network. So the point I am trying to make is that the internet of today is a best effort network. Best effort network meaning that your video streams are going to the same network, your voice is going on the same network, your emails are going to the same network, your Gmail communication is going on the same network. So they are all competing for the same resource. It's like you have a highway, and you have a highway whereby cars are going, your bullock carts are going, two-wheelers are going, and 18-wheeler trucks are going. They all are sharing the same road. And if they all are sharing the same road, some transport vehicles will be going slower because there are big lorries. Trucks will slow you down, or there are cars then because there are a lot of cars. The two-wheelers who could probably go faster and could go any way they like, they can go fast enough. So when they are all sharing the same resource, nobody is getting the quality of service. So the problem of today is that the internet of today is shared by everybody, by all kinds of applications, by all kinds of services, from data to video, watching Bollywood movies, or news, or TV programs, or whatever. And the result of that is that people who want to send emails, or those who want to talk to somebody or want to have a conference call, they get interrupted service, or they don't get a good quality of service. So that internet that we have today is called best effort internet. So everybody is sharing the same network. And we all know that 80% of the network resources are being utilized by video. There's a lot of entertainment information. Like people are using WhatsApp or Facebook or whatever, and they are watching video streams, little clips, or TikTok or whatever. So 80 to 90% of resources are being used by this kind of traffic, which is affecting the more meaningful business applications, which are more useful in our day-to-day life. So if you go and talk to Jio, and if you talk to Idea, Vodafone, or to Airtel, they want you to watch more and more video. They want you to watch more and more movies so that they can sell you more expensive data plans, because that's where they make the money. And that's why they give you unlimited capability to make phone calls. You can talk as much as you want, because talk utilizes very less network resources. Maybe 2 to 3% of resources are being utilized by voice as opposed to data. So the network slicing, what it does is it is dividing the network into slices, so that the voice goes only on the voice section, voice slice of the internet. The video goes only on the voice part of the internet. And maybe a business application goes on a different slice. It is similar to virtual LAN. Probably you have read in your communication theory course about virtual LAN. Virtual LAN is that you have the same Ethernet infrastructure in this campus, but I can create a VLAN just for electrical engineering department. I can create a virtual LAN for computer science department, another VLAN for administration, and so on and so forth. So the traffic that is going between electrical engineering department, that stays within that VLAN. And when it goes from VLAN to administrative part of the Ethernet of the virtual LAN, it gets switched internally without you knowing. So we are able to segment the Ethernet infrastructure that we have on this campus into many different virtual LANs. So the question that arose was, why can't we divide the internet, the global internet, into slices, so that each slice carries a different kind of packets. So the service is not affected. The traffic that is going on one slice doesn't affect the quality of service of the traffic that is on the other slice. That is the main reason. So it is like logically dividing the internet into many different slices. So if people are watching video, it will only remain on a video slice. So people who are making phone calls, or if you have different type of applications, or healthcare application, or educational applications, their services are not impacted. So their quality of service is maintained. They get the same latency and throughput as they should be for their application and for their service. That's the basic idea about network slicing. So this is a very revolutionary concept that is being applied in 5G network. So right now, from 4G, in what happens in 4G, the moment you speak in your mobile phone, your voice gets into a packet as though it is a data packet, and it goes into the packet-based network. Before 4G, the voice used to go as a circuit switch packets, slots. So up until before 4G, the mobile networks, they used to maintain two different type of networks. One was for carrying voice, and another one was carrying for packets, for data. So the problem for Airtel and Vodafones of the world was that they had to maintain two different kind of networks, which was very expensive for them. But with the arrival of 4G and LTE, which is called long-term evolution, everything is going on packet network. So the moment you speak on your phone, it gets packet, and there is a header attached to it that says this is a voice, and it goes to the other end, and it gets metered, and there is authentication and everything else that happens. So the mobile operators, they have to maintain only one network. So they're shutting down this circuit switch network all the time. So that is what they are able to do, and they are able to create more efficiency in the network, and they sell you one data plan, and that carries voice data, video, everything. Okay, so that is what has happened in the mobile network as we have gone from 3G to 4G, and as we go to 5G, one of the basic concepts that is coming up is 5G. So another thing from a business standpoint is that whether I am selling my data plan to a company, to a hospital, or I am selling it to an individual like me and you, I am selling the same data plan. I am selling the same data plan or data plans to the employees and the owners of a business as I am selling it to an individual. So they are not able to make money because they are selling the same plan, right? It is costing the same thing. Even though the hospital is able to pay more, or an insurance company is able to pay more, or a manufacturing company or an automobile company is able to pay more. So with the network slicing, what the mobile operator will be able to do is they will be able to create a slice just for Maruti Suzuki. So Maruti Suzuki is all over India. They'll create just a slice for Maruti Suzuki or for Tata, and they will be able to charge them more for that service. And they will give a guarantee to Maruti Suzuki, Tata, or Mercedes, or any other company, or a hospital. They'll be able to charge more, but they'll be able to guarantee the quality of service much better than you and me and to somebody else who is more busy with the entertainment information and just having fun, enjoying because I have dead time. I'm not doing anything, so I'm just killing my time. So that is why the mobile operators are very much interested in this concept of network slicing, so they can create a slice for a company, for a business, and they can charge them differently than they charge to a commercial or an individual consumer like me and you. So from a business standpoint, network slicing is very attractive for these mobile operators. So that's the point I'm trying to make. Why network slicing is such an important point. Okay, let me go to the next slide. I hope it advances. Can you go to the next slide? Yeah. Okay, so this is the one, right?
Sir, this is
All right. Okay, let's go back. Let's go back to okay. Go back.
first forward,
Okay.
backward,
Okay.
side, side.
Okay, so I already gave an outline of my talk. The time is limited, but I'll try to keep it as simple so that you remember a few things as you go after my talk. Oh. Hmm? You just advance it for me. Okay, so up until those of you who have been learning about the communication network, I was telling you that one size fits all has been the solution so far. There's one network fitting everybody, meeting the needs of all the applications. But this network slicing concept, it is revolutionary that it breaks the old approach of building the networks. Up until now, people have been thinking about, if you look at the first line, you look at network of entities and architecture. So if you think about network, it used to be of routers, firewalls, about deep packet inspectors, about switches. They all used to be hardware things. that were sitting in the network. If you put them all together, you will have the network. But now we are moving into the world where we don't talk about the architecture of the network and about these entities. The new trend is to think about network of capabilities. What this network is capable of doing, not about what it is made up of. That's the change in thinking. That's the approach that the manufacturers are taking. Similarly, there used to be this network for connectivity model. That network used to provide connectivity and you carry whatever you want on top of it. But now we are going to the era of network for services. We are building network for services, not providing the network. It's not about like building the roads first. That is the infrastructure, and then whatever goes will go on top of it. So network is the same way that you don't need to build the network, it's all software. So the future network are not built, are not made up of these network entities like routers, firewall inspectors, about switches. All of these things can be built in software nowadays because of the density of the transistors you have, the computing power that is there nowadays. So that is the trend, that the network is made up of completely software, is built of data centers and servers. That's where the trend is that is happening. And so that's the point. Okay, can we go to the next one? Okay, now we talk about throughput, about latency, about delay. You know, whenever we are playing a video on WhatsApp, for instance, and if the speed is slow, it will play maybe for 1 second and then it will stop, then it will restart again, and so on and so forth. And that gets very frustrating for all of us. And that is even worse for the businesses who are trying to run a business. So nobody likes to wait, especially the younger generation. They do not want to wait, you know. They have the lack of patience. So let's go to the next slide. We are getting an era of people are buying online. You are paying your bills online. You are paying for whatever you buy using Paytm or Phone Pay or whatever. You want to make the payment very quickly, right? If you want to buy something from Flipkart or from Amazon, you want to do it fast. So this online business is growing every year. So these online sellers and service providers, the latency, if you don't get the service from them, they lose business. And here are some numbers, the real numbers. What happens? So when you go to Google, if you are looking for a certain service, you go to do a Google search. Google has some very interesting algorithm where they will they'll present you the results of the searches. And if you go to a website, and if that website is not loading, or if it is taking too long, you go to the next one. If that is taking a lot of time, you go to the next one. So people don't want to wait. So they'll go to whoever is providing the service which is fastest to you. So here are some numbers. So some of these numbers are about 10 years, 12 years old when I had done the research, but I haven't updated it since that time. So Google had found that 500 millisecond, if there's latency for you to go to the website and do something, is 500 milliseconds slowdown in loading a page equals 20% decrease in ad revenue. Google makes money from ad revenue, right? We all know that. So their revenue goes down by 20% if it takes 5, because people go to somewhere else, because they make money from sponsored ads. So this is the impact on their revenue. Microsoft Bing, when Bing was being offered, they found that a 2-second slowdown meant 2.5% decrease in queries and overall clicks. That affects their revenue. Amazon found that a 100 millisecond slowdown can mean a 1% decrease in revenue. So if some of these companies have a revenue of 100 billion, a 1% slowdown is a billion dollar reduction in their revenue. So these are the real numbers that affect their businesses, and the same thing applies for companies in India as well. Yahoo found a similar thing. Mozilla found mapped a 2.2-second improvement. If you improve the loading time of their page, gives them 60 million additional Firefox downloads, for instance. So basically, it's all about experience. You want things to have. Nobody wants to wait. So the performance is very critical, and there are two things about this. One is the connectivity. Your connectivity has to be broadband, and number two, the way you architect your web page, and the way you deliver it fastest is how the page will load to a user. Can you go to the next one, please? And then it affects the brand also. If a website is always slow, you think, oh, this is a lousy place, I don't ever want to go there. It applies if you want to buy a railway ticket or a bus ticket. You go to certain service providers because they provide you faster service. So it affects the brand of the company. So tolerating latency is no more an option. Go to the next one, please. So the next slide is also quite interesting. So when the computers were built in the 1950s, 1960s, and 1970s, I remember when I was going to college here in 1970s and 80s, the computers used to be in a room that were air conditioned and nobody was allowed to enter there, only the computer operator will be there. So yesterday's computers filled rooms. They had these tape drives, punching machines, and CPUs, memories, and all that. So this is how the world used to be. This is how it was before. Can we go to the next slide, please? Now, today's computers are also filling the room. It's no different. So are today's, more so will tomorrow's, because now everything is connected. Every device we have in our living room or drawing room has computing power and has connectivity. From your TV is connected to internet, your mobile is connected with internet, your tablet, and with the arrival of IoT and maybe thermostats and refrigerator. So we will have computers, your room will be full of computers, and you'll be able to control all of them through some kind of a remote or through your smartwatch if you are wearing that, and all kinds of. So basically, even the computers used to fill the room yesterday, but they are doing the same thing today, and they will do more and more tomorrow as everything has this wireless connectivity, and they get connected with each other through a hub or through mesh network with some kind of a control point that you control through a remote or through your smartwatch or through an app on your mobile phone. So this is the era that we are living in. It will evolve into. Next one. So what is a network slice and slicing? So some of us have heard about infrastructure as a service, software as a service. So cloud is playing a big role. Like if I have a Gmail, if you are doing WhatsApp or Facebook's whatever, everything is in the cloud. You are running a client on a mobile phone, but everything is in the cloud, and those resources are owned either by Google, Facebook, or somebody else. So everything is running in the cloud, and cloud is nothing but a data center. Data center is where the service providers databases are, their applications are running. They are running in the cloud, either in one data center or it is distributed across many different data centers, and it is duplicated also. So that if one data center or a server fails, you have uninterrupted experience. So everything is already running in the data centers nowadays. So you have heard about this service called infrastructure as a service, software as a service. So cloud, Amazon Web Services, you probably have heard about. So Amazon is offering these cloud services, and that is growing very fast. So similarly, Microsoft is offering their cloud services, and even though the revenues may be small compared to what their overall business is, business revenues, but these are the fastest growing businesses for these companies. So everything is getting cloud. So the network of the future is also going to be cloud based, right? You do not need all these routers and firewalls and all these traditional network equipment that we learn in our courses today. You don't need to have those. Those things are done in software. As long as you are able to connect, and then you do everything in software, and that can be done in the cloud. Like if I have a set-top box in my house for the TV, I really don't need a set-top box. I only need some kind of a remote that connects with my set-top box, and that set-top box just converts that signals into packets, and that packets goes to the cloud, and it is executed in software. You don't need hardware. So this is where the world is evolving, but this connectivity has to be fast. You have to have this broadband connectivity. If you not have, if your connection is slow, then your response is going to be very slow, and that is going to be very frustrating. And that's why you are seeing a lot of fiber deployment coming to home, fiber going to your businesses, your companies, and also 5G being deployed, 6G around the corner, people are looking into 6G. So you get 1 gigabit per second of bandwidth over the access network that is being terminated in your home. Okay, so there are several definitions of network slicing, and in very simple terms, I already told you what network slicing is. It is dividing that internet of today into many different logical networks so that it serves a certain industry segment, maybe healthcare segment, or an operator can provide a network slice for a chain of hospitals like Apollo Hospital. They provide a network just for them. And another one for some transportation company, another one for railways. So all of these are slices. So those slices can be provided either for the type of data that is going through it, or for a customer, or for a different for a special type of a service. So that is the definition of slice. But the problem is, but there are big challenges, because if you are creating a network slice, then it has to go to different network domains. So I may be subscriber to Jio, for instance, right? And the person I want to talk to is subscribing to Airtel, right? And these two networks need to talk to each other, correct? So if I have, or similarly, a hospital may be on Airtel's network, another hospital may be on Jio's network. So they have to have the same kind of a slice. If one slice is fatter, bigger than the other smaller slice, then the service will be affected. It's like when you are going in the city, you can have a beautiful highway, which is a 4-lane highway on each side, but once you exit, and if you have just a 2-lane highway or a 1-lane gully, narrow street, everything is going to slow down. So this is the same kind of thing, that these two different networks, they need to have some kind of a contract and agreement that they will provide the same width of the slice and same network parameters to provide the quality of service end to end. End to end meaning from one mobile device to another mobile device, or one end user device to another end user device, or one end business to another end business. So that is what the difference is. There is another concept is called called software-defined network. And I'll give you a very good example, you know. All these companies, even this university, the government, they have data centers. This university probably has a data center, there are servers somewhere. There was a time in early 2000s, up until 2005, 2010, these data centers used to be huge. Like Google used to have data centers, where there will be servers, and these used to be full with servers, and they used to have duplicate servers to run the same thing, same application, so that if one fails, the other one will come online in a hot fashion. So there will be uninterrupted service. So the big companies like Google and Amazon wasn't there at that time. But anyway, but all of these big companies, they used to have data centers that used to be big, and that cost them a lot of money because they needed to have their building, they used to have duplicate servers, they needed to have air conditioning, because these data centers used to be very noisy and very hot. So they needed air conditioning. Air conditioning meant a lot of energy cost, paying for electricity. So this is what used to be in the IT world. But what happened in the early 2000s, like 2005 and 2010, those of you who have a background in computer science, you probably have heard about something called virtualization, virtualized servers. So one server can run many different operating systems and many different applications. So up until 2005, 2007, 2010, one application on an operating system will run on one server. And if you have the same application running on a different operating system, it will require a different machine, different server, different hardware. And all of these hardware servers, they were running at 20% or 30% or 15% utilization, and 80-85% was not being used, even though you were cooling it. But with the arrival of virtualization, you could run them up to about 80 or 90%, and I'll talk a little bit more about that. So there is this concept of software-defined networking. So the IT industry went through a big revolution around 2005, 2010 time frame, where all the data centers around the world, they got virtualized. So you are running a computer, not as a hardware, but your computer is a software also. One server, but one server is running many different computers at the same time. So you have these data centers that get virtualized. But their networks, communication network, they never got virtualized. They were running all these routers, and they have been very traditional, and they have been very slow to transform. So up until recently, the mobile networks, the internet or the communication network, they have all been very hardware based. Now we are entering an era where the communication network will be all software based. So you'll have data centers that will run all these network functions in software, and these network functions will be interconnected through some fiber links inside the data centers or to another data centers. So telecommunication network will be all software based. That is what is happening today, and it is going to happen more and more into the future. So the telecom networks of the future are going through this big revolution of softwareization. And for softwareization, there is a technology called software-defined networking. There is a protocol for it. I don't want you to go into the detail here, because there is standards for it. From ETSI, there are standards from IEEE and many different places. There are industry fora that are developing these standards. And there is something called OpenFlow. OpenFlow is a protocol that sets all these things up, routers and all that. Go to the next one. So virtualization, as I was telling you, virtualization of the network is going to disrupt the telecom network in a big way. So even though it is nice to learn in your coursework about 7-layer protocol stack, TCP/IP protocol, and so on and so forth. Great to learn about it. But a lot of the things that you are reading, they are going to be done in software. Just remember it. So if you have skills in software-defined networking, open flow, virtualization, those are the kind of skills where the job opportunities are. That is where the employers are looking for. If you go for an interview and if you are able to say, well, you know about software-defined networking, what it is, you know about how to build a router through software, you have a much better chance of getting recruited than telling that I know only the protocol stacks. So this is the point from a employability point of view that I wanted to make here. Some of the key organizations, okay, so this NFV SDN, which is virtualization of telecom network concept, was born only in 2012, when 12 of those companies came together and they said, well, IT industry has gone through this big revolution, why shouldn't we be doing the same thing? So the softwareization of telecom network is a very new concept, only a decade old, and it is happening now, but it is happening slowly. And some of the key organizations, standards bodies that are driving it, they are European Telecom Standards Institute, 3GPP, Open Network Forum, and so on and so forth. You don't need to remember about all those things. So you got the basic point, is this softwareization of the telecom network. Next one, please. Next one. So this is something I was talking to you about, the virtualization of the data centers. I was telling you verbally. So in the old times, if you had an, okay, right now you have a mobile phone, right? We call it, are you running an Android, or you're running an Apple's operating system, or you're running somebody's operating system on a mobile. So if you have an app that runs on Android, it will run only on Android, right? But imagine if your mobile can run all of these operating systems. So potentially in future, you'll have a mobile phone that will run Android, that will run Microsoft's operating system, that will possibly run Apple's operating, iOS, and so on and so forth. But the same thing happened in the data centers. So previously there was an application that was running on an OS, and that was running on some dedicated hardware. That was a hardware server. That's how, that was a traditional approach. So these data centers used to be huge, and that on the left hand side it used to run at 20-30% utilization. 60-70% it was not being used. So now what happened? In about 2008, 2009, some companies, they came up with this great idea of virtualization. So there is a hardware, and hardware is nothing but you have a memory, you have a computing power, you have drivers, you have some kind of a display NIC card, and you have a concept called hypervisor. Hypervisor is a piece of software that will give you different operating systems on the same hardwares. So you have these hardware resources, and you will have a softwareized operating system A, B, C. So you can have a Linux, you can have a Microsoft operating system, you can have any number of operating systems you have, and you can have virtual machines. So you can have many different computers running on the same hardware. So the hardware will be running at 80 or 90% utilization. So you are running now at you are running your operation much more efficiently. That's the whole point. So the real estate that you need, the space that you need shrinks. And now these virtual machines, the other thing happened, these virtual machines you can run at any other place. So I can have a virtual machine that is running an application here in Visakhapatnam. I can have a virtual machine running in Bangalore also, if I want. And I can have duplicated application, same application running at that place. So if my virtual machine fails here, it will automatically move over there. without any interruption in service. Or if I want to move my application from here to a data center in Delhi, I can move that application to a virtual machine in Delhi just as I move a file on my computer, on my laptop, from one folder to another folder. This is the beauty about this idea about virtualization. So even though we have these data centers, these are virtualized, these are at different locations, and the network operation center, the person who is controlling, he has a complete view of the whole thing. It's like a control center, and his company, whosoever is providing this cloud service, is looking at these things. He knows where the things are failing, where it is not failing, where it is running at 30% utilization, which is running at 80% utilization, and the person can just move those applications from one place to another place. It has given tremendous amount of flexibility in the IT world. That's why Google is able to do all of this. Okay? So this is the important concept of virtual machines that I think everybody should know about. Everybody should know about how the data centers are built today. How the virtual machine, what the virtual machine is. In the virtual machine, you can run a route, you can build a software router, you can build a software switch, you can do any network function, anything you want in software. Because the computing power that is there, it runs very fast nowadays, so it is as fast as the hardware will do. That is the beauty about virtualization. Next one. So this is the whole saying here, that up until now we had all these dedicated pieces of hardware in the network. Now it's all running in software. That is what is represented on the right hand side. Next one. Can you do the next one, please? Same thing is being shown here, that you have a hardware resources. So these are off the shelf, meaning traditional. Go back, please. Yeah, this. Go back, yeah. Go back. Back. Yeah, this is, oh, okay, go after this, 2 slides. Yeah, one more. Okay, this one. So what is this showing is that we have a hardware resources. Hardware resources meaning you have a lot of computing power, storage power, and network power. These are hardware. And I can have a virtual computing, I can have a virtual storage, I can have a virtual network. I can build all of these through that thing on the right hand side, which is called NFV, Management and Orchestration, with a vertical block. I will interact with that, and I can have virtual compute, virtual resource, and virtual network. And by controlling those things, I can build any kind of a network function. That's what it is trying to tell in a very simple way. Go to the next one. Yeah, please skip, yeah, this is too much detail. Let's not go through this also. Go next one. Yeah, this one. Okay, this is an interesting slide to look at. I don't think you are able to see it. Can we go in the slideshow mode? Bigger? Slideshow mode. Slideshow. Keep going, keep going, keep going. Yeah, this one here. Oh, okay. So, some of you have already know that the work has begun on 6G. So, what this 6G is about? So, the picture in the middle that is showing the 5G. There are these performance requirements that were defined for 5G. And some of the performance requirements for 5G were that everybody will get up to maybe 1 gigabit per second of speed when you are close to the tower. And when you are away from the tower, at the edge of the tower, you'll get up to about 100 megabit per second. Everybody will get 100 megabit per second. Similarly, when you go to 6G, the aspirational networks requirements are very different. So that if you go to the, if you are close to the tower, you'll get up to 100 gigabit per second of speed. If you are away from it, you'll get about 10 gigabit per second. So these are the numbers. How much latency? Latency will, for 5G is about 1 millisecond right now. And for 6G it will be 0.1 millisecond. So these are the new type of performance requirements that have been defined for the next generation of mobile network, and the standards are being developed for that. Yeah, please go to the next one. Okay, let's, basically this is showing that what are the bandwidth requirements for different kind of applications and latency. So basically if you have a sensors IoT, then sensors don't require very little latency. Latency can be very large. So it can be up to about 10 seconds, and bandwidth can be only about 0.1 megabit per second. But if you are running remote surgery, if you are doing a remote surgery on a patient which is hundreds of kilometers away, then the latency needs to be around 100 microsecond to 1 millisecond, and the speed needs to be about 1000 megabit per second to deliver you that kind of a latency. So basically, with different kind of applications, there are different kind of requirements, and that will be possible to be delivered by 6G network, and again by network slicing. So if I have a medical application, I will create a slice just for medical, and I will give 1000 megabit per second of throughput, while I will reduce the resources and the bandwidth that is given to other application. Next one. Okay, let's skip this, too much detail, and let's skip that. Yeah, let's keep on going. Yeah. I don't want to go into these details because you won't remember them anyway. Keep going. So now, some of the important requirements of network slicing is that they should not interfere. One slice should not interfere with another slice, because you're building a logical network. So your hardware resources are the same, but there are many different slices running on the same hardware. So you don't want one service to affect the service of the other slice. And there should not be any security compromises also. Security is one of the important requirement also. Next one. Can we go to the next one? Yeah. Okay, let's go. What's the time now? Okay. No. Okay, let's keep going. Yeah, let's go. What is that? No. Can we advance the slide? These are some of the standards organizations that are working on network slicing. These are some details that you don't need to remember. Keep going. Okay, we can stop here for spend 3 or 4 minutes about what network slicing can do for rural communication. Okay. So, you know, in a country like India and other parts of the world, about 3 billion people together, all over the world, they still are not connected on the internet. Or they are underconnected, meaning they don't have enough bandwidth, or they don't know how to use internet, or they don't have these smartphones, or they are not digitally capable of what you are able to do over the internet using smartphones or smart devices. So how do we bridge this digital divide? And research has shown that if you increase the internet penetration in a population by 10%, your GDP of your country goes up by at least 3 to 4%. So it's a big contributor to the wealth of a country. That's what the research has shown. So a country like India, and why the present central government, they're investing very heavily on digitalization of the country, you know, through Aadhaar or through UPI payments and so on and so forth, and through QR code and all that wonderful things are happening here. But still a lot of people in the rural areas, they are not able to use internet the way we use. So there is a big digital divide. So actually digital divide threatens our society. About 3 to 4 billion people are unconnected or underconnected, and there is a huge cost for the society because they don't develop sufficient digital skills, and they are not contributing to the labor market. In the digital labor market, they are not able to sell their goods and services, their handicrafts, and they are being exploited by the middlemen. Basically, our farmers, they produce something, but who really makes the money is a middleman who bring the produce to the marketplace, but these farmers still don't make the money. And the same thing happens when it comes to handicrafts and all the other things. But if they are digitally capable, maybe they can sell their goods and services over the internet directly to the consumer and make more money for themselves, while it is costing the same thing to the end user. If you are interested, so the cost to society is huge. And if you are interested, you should read a nice book on the price of inequality. It is huge on the society. And this book was written by Joseph Stiglitz, who's a well-known economist. So digital divide, because of digital divide, they don't get enough information about health, about education, about decent work, about equality, gender equality, women empowerment, and so on and so forth. So those are some of the challenges which prevents people to become part of the digital ecosystem. Can we go to the next one? So slicing, so there people have been looking at how to provide internet to the rural communities as cheaply as possible and maybe free of cost, because these people can't afford to pay for the data packages which are being charged by the mobile operators. So there are a number of solutions. So maybe an entrepreneur builds an infrastructure in the village, but if the users are very few, then he or she cannot recoup the investment. So, but what can happen with network slicing? An entrepreneur builds an infrastructure, but he breaks this infrastructure into many different logical networks, and he sells it to different service providers. So right now, many mobile operators, they are not interested in providing network connectivity to rural areas. When we are driving on the highways, we feel that the country is well connected. But if you go to the rural areas, you'll find maybe you have the phone connectivity, but there is no internet, or you are getting just 2G bandwidth or 3G, which is not good enough. So if you go maybe 10 kilometers or 5 kilometers away from the highways, there is no connectivity. So this network slicing allows that you build infrastructure and you build many different slices, and each slice is offered to a different network provider or a different entrepreneur who will offer the service and will be able to make money. So network slicing is very much applicable in the rural environment as well. Next one. Yeah, keep going. And we call those entrepreneurs as mobile network operators. This is another concept that I was talking to our colleague Dr. Chakravarti about, Prime Minister's Vani. This is a very nice concept. What the government has done is that they have removed all the requirements of anybody being able to offer Wi-Fi services, public anybody can offer public hotspot nowadays in India. It has been completely deregulated. You don't need to get any license from the government. You don't need any of that. There is no bureaucracy. You only need to register your Wi-Fi hotspot with the CDOT right now. CDOT is managing the service. You just register your hotspot with the CDOT, and anybody who walks into your hotspot, that person will register and will get a user ID and password and can log in and start using it. Like the PCOs we used to have before. You know, we used to have these phone booths. You walk in and make a phone call, you pay for it and you go away. So these are PDOs, public data offices, where anybody can offer a hotspot, and if somebody goes from one hotspot to another hotspot in the same city or other part of the country, that person can start using that hotspot with the same user ID and password, because that person is authenticated by wherever the registry is maintained, so he or she is authenticated without the need to have an OTP and all those things. So this is providing roaming. This is like providing roaming across public hotspots across the whole country for people who don't have a broadband at their home. But the interesting thing is a lot of these phones already have a hotspot. So that is where the challenge is coming for PM Vani solution that has been developed by CDOT and blessed by the Ministry of Telecommunication in India. Very excellent concept, and it is being standardized by IEEE right now for as a global standard. So which is great for India as a country to develop this thing. Maybe not appropriate for India because people are carrying these phones with hotspot. But if we go to other parts of the world like Africa, people have asked me when can we have it. But the Indian government and CDOT, they are still waiting for some regulatory approvals to be able to offer it outside of the country. Okay, so let's stop it here. Can we go to the next slide? Okay, so with this, okay, go to the next one, then I'll come back to this. So one thing that I wanted to say, that when we are learning about communication theory, or we have got so many people in telecom, or enrolled in electrical engineering course or electronics engineering course, sometimes we all think about that mobile communication, telecommunication is about radio, about networking, which is not true. And this slide shows that communication is about electronics and materials, it's about wireless communication, it's about computer science, it's about data science, it's about AI, it's about analytics. So telecommunication is about all of these fields, and this will become apparent when I show you the next slide, which is a video. So basically, there is a lot of interest in building nanoelectronics because we want to be able to put as much power and memory as possible in these mobile phones or mobile devices. So there is a lot of interest in nanoelectronics, which is about electronics, not about communication. It's about chip design, about RF modules. You know, every phone has got so many antennas. We have got a GPS, we have got Bluetooth, we have got maybe LoRa, we have cellular interface. So how can we have so many different kind of antennas operating in different parts of the spectrum? So we need antenna technology that will, same antenna will operate in different frequency ranges at the same time. So tunable transmitter receivers that will have a very wide band operability without a non-uniform attenuation. So this is a challenge, RF modules and packaging, how do you do that? High frequency materials, material technology is huge. You know, how do we build a foldable display where the screen is foldable? You can give it any shape you want, not flat. And Samsung has already delivered these curved, and other companies have delivered these curved televisions already. So how do you have these flexible displays? Energy harvesting. How do I harvest the energy on my, like I'm in this room, I've got all these lights. Can I have some kind of a cell that will capture light around me and charge my mobile phone even from ambient light? Even though it is slow charging, but it is charging. So this energy harvesting is a technology. Imaging is the other one. Similarly, wireless communication plays a role because you want to give mobility. Wireless communication radio is important because of the need for mobility. And then it's all about computer science analytics. When you're running an application, the service provider wants to collect all information about what you are using, when you are using it, who you are buying from, what is your profile, how much you spend, which store you want to go to. It's all data collection. And when you have collected all this information, where you live, whom you talk to, and when you have collected all this information, they can utilize that information and sell it to advertisers or insurance companies or retail shops who will send you offers, discounts, and all those things. So data science, artificial intelligence, and providing a customized UI for an application, those become big opportunities. So computer science is huge. That's why this AI, machine learning, all of those things have a big role to play in telecommunication, because you are running an application, but the telecom operator, they just don't want to provide you the connectivity. They don't want to provide you the pipe to deliver packets from one to another, because they want to get information about you, and they also want to make money. Then the Googles and Facebooks and Microsofts of the world who are making money on top of whosoever is providing the infrastructure. Can we go to the next previous slide, please? Yeah, this one. Okay, so I will show what I was talking to you about. This will probably make sense to you when I show you a video about the future, what it looks like. And there are some videos about how the containers are being handled in a shipyard. You know, Vishakhapatnam being such a big port, you have got a lot of containers coming, shipments coming, they're being unloaded, and how they are tagged, what is in them, and so on and so forth. You'll see the technologies. People are using Uber, Ola. Now you get Uber, Ola, and you're looking for the license plate of the taxi, where it is standing. You're searching for it. How the location service is used to go to where the taxi is. When you go close to the taxi, how that information will get displayed on your mobile, and so on and so forth. So there are some really amazing applications that you will see in the future. So what we are experiencing today is just the tip of the iceberg, and hopefully if this video runs well, you'll get an idea about the kind of opportunities. And those are the kind of opportunities that the startups are very good at delivering, and they are very good at building, and they're very good at offering to the end users. So can we play this video? Let's click here. Click to play video.
challenges.
No, that sound is fine. Yes, I close this window. The video is not coming, but the audio is there. probably this video showed that there are many different technologies involved. The connectivity just is a part of it. And there are many different types of connectivity, long range, short range, but the context is very important where you are to be able to determine where the person is, what you're doing, and being able to leverage flexible displays, flexible screen. And you probably saw an example of every bottle. As we have today, it has a label, right? Some kind of paper label on it. We probably won't need a label. And it will be programmed. The label will be programmed, and when you maybe look through your phone, you'll just see the label. So you don't need to, it becomes more recyclable, and it saves the cost. So these are all kind of new kind of innovations because, as you know, it's all about the user experience. And the final thing that I wanted to say that the researchers are working on other kind of human senses. Right now we are able to exploit only two senses. One of them is being able to see and hear. So it is audio and visual. But there is some research going on being able to smell and on being able to taste and on being able to touch. Because even though we are able to touch right now, the touch basically is to activate something or deactivate something. But touch has got many different dimensions, such as how hot a surface is, how rough a surface is, how smooth a surface is, and so on and so forth. Similarly, smell has a big role to play, because if I'm at a place in a garden and there are a lot of nice flowers, and I want to share that I'm in a garden sitting among the flowers and how good the smell is about the flowers, the food I'm eating, I can utilize my device to be able to communicate to the other person what the smell is. So these smell-based sensors and smell-based synthesizers and taste, these are all chemical sensors. So people are looking into what are the safe chemicals, because they have to be safe, because you are smelling or you are tasting, and it also involves how do you activate those things, how do you synthesize the smell. Once you capture the smell, you can digitize it and send it to the other end. But then you have to recreate that. How do you recreate it? And there are some successful lab experiments that have been done. And the way the manufacturers, they are able to get ahead of their competition is being able to deliver a better experience, more advanced system, for that they can charge more. So surely there will be manufacturers who will come up with devices that will provide some of these capabilities, even though they may not be perfect, but they will be cool enough that people will be willing to pay more for those things. So those are some of the things that are happening in the research arena, and I hope I'm able to give you some idea about the opportunities that lie ahead of us, and about how you can use your learnings and basic knowledge to apply to some of these use cases, applications. Because that is what ultimately sells in the marketplace, and that is what the employers are looking to do, to utilize from graduates or postgraduates or people who have some experience. So with that, I'll stop here. I'll be happy to take any questions that you may have.
I would like to thank our esteemed speaker, Sudhir Dixit sir, for the lecture on network slicing on 5G and beyond its implications on rural connectivity. The insights shared today have given us a deeper understanding of the technological advancements. We have now a clearer picture of how network slicing is transforming the way we connect and communicate. Sir, on behalf of everyone present here today, I'd like to express our sincere thanks for sharing your knowledge and vision with us. We hope to have the opportunity to hear more from you in the future as this field continues to evolve.
Dear attendees, your feedback is very valuable to us. Now I request any one of you from the audience to come forward and